Hello students, myself Sankalp Gharat. I welcome you all to today's session of determination of HLB value. So first of all, before starting with this session of determination of HLB value, we would first see what are the excipients for which HLB value is calculated and why and what is the need of calculation of HLB value. So on your screen, now I'll be showing you some of the formulations which are marketed and which we use on a daily basis, which has this excipient, which is known as a surfactant, for which HLB value is calculated. So on your screen now, you can see there are n number of formulations of cosmetic grades. There is a Vaseline, okay, body lotions, um, shaving creams, shampoos, okay. So these are the different products which are available in the market and which we use on a day-to-day basis, in which surfactants are present. So these are the cosmeceutical products which are present in the market. Now comes on your screen, you can see these are the various pharma grade formulations. Okay, so these are also emulsions which contain surfactant into it. So here comes the role of HLB value. As we are using surfactant in all these preparations, we need to assess the HLB, that is hydrophilic lipophilic balance of this surfactant, which will help us to choose a correct surfactant while formulating any of the product. Okay. So what is the role of surfactant in emulsion? So when we mix oil and water, okay, it would be physically, it won't get mixed unless and until we add a surfactant. So in the first case on your screen, you can see oil droplets are dispersed in the external phase, that is water. So in this case, what surfactants will do is it will reduce the surface tension. It will adsorb onto the surface of the oil globules in such a way that hydrophilic head would be facing the outer compartment, that is the water phase, and the lipophilic phase will be facing, or the lipophilic tail would be facing the inner oil globule. So that is the reason the oil would be dispersed as small globules in water. On the second hand, if water is dispersed into oil, in that case surfactants will form reverse micelle, in which the hydrophilic heads will be facing inside and the hydrophobic tails will face outside. So in this case, the middle core will coat the water globules. So how and when this HLB scale was introduced? So HLB scale was introduced by William Griffin in 1954, and as you can see on the screen, it has a hydrophile, that is water loving head, and lipophile, that is oil loving tail. So depending upon the globule which we have seen in the previous slide, this surfactant molecule will orient in such a way that either it will coat a oil globule or it will coat the water globule, depending upon the dispersed phase. So HLB values are calculated for non-ionic surfactants only. And once this HLB values are calculated, it would be easier for the formulator to choose a correct surfactant. So on your screen now you can see what are the different examples of surfactants. So in variety of products we use oleic acid, okay, span 65, span 80, span 20, okay, sodium octanate. So these are the different grades or different types of surfactants which are used along with the HLB. So HLB values for those corresponding surfactants are given on your screen. So these values are calculated using the experiment which we are going to study today. Okay. Basically, all these surfactants, once the HLB value is calculated, this HLB scale is used. So this HLB scale on your screen, you can see it is the general HLB scale from 0 to 18, which from 0 to 6, okay, the surfactants which are having HLB value from 0 to 6 are hydrophobic ones, that is those are oil soluble ones. So any surfactant which is having value from 0 to 6 are hydrophobic ones, and these can be used as anti-foaming agents and for as an emulsifying agents in water in oil emulsions. Then comes 6 to 9 range. So these are the water dispersible kind of surfactants which are used as wetting agents and spreading agents. Then from 9 to 18 comes the hydrophilic kind of surfactants which are water soluble ones. So if as a formulator you are formulating oil in water emulsion, then you can select a surfactant with HLB between 9 to 16 or 8 to 16. If you are formulating any detergent kind of a thing, okay, or any formulation which has a detergent into it or cleansing action, then surfactant with range of HLB between 13 to 15 can be used. And if you are using surfactant as a solubilizing agent, so in that case surfactant with HLB scale 15 to 18 can be used. So just see how this HLB scale would be helpful to you in choosing a correct surfactant for a correct product. So this is an extension of the HLB scale which you have seen previously. So supposingly if you are mixing two unlike oils together, so in that case we can use surfactants with HLB 1 to 3. If you are making water in oil emulsion, so that is water globules are dispersed in oil, so in that case we can use surfactant with HLB 4 to 6. Then comes wetting powders into oils. So supposingly if you need to add a formulation has a powder which has to be dispersed into oil, so in that case surfactants from 7 to 9 can be used. Then self emulsifying oils. So for these kind of formulations, HLB from surfactants with HLB from 7 to 8 can be used. Making oil in water emulsions. So for oil in water, so oil is dispersed into water phase. So in that case, surfactant blends of HLB from 8 to 16 can be used. So for detergent solutions, HLB from 13 to 15, and for solubilizing agent for micro emulsification into water. So in that case, surfactants of higher HLB, that is 13 and above, can be used as a surfactant for giving the appropriate purpose, for serving the purpose. So today's experiment is, our aim is to determine the HLB value of a given ester. So what is the ester? Over here we are going to take is glyceryl monostearate. Requirements would be water bath, will require one round bottom flask, a condenser, zero point 0.1 normal NaOH, 0.5 normal HCl, and 0.5 normal alcoholic solutions. Okay, so today we are going to determine the HLB value of an ester. So this is a surfactant glyceryl monostearate. Before finding out the HLB value, we first need to find out saponification value and acid value. So once saponification value and acid value of a given ester or a surfactant is calculated, only then we'll be able to find out what is the HLB value of that particular surfactant. So we'll start with saponification value. So what do we mean by saponification value? Saponification value is defined as the number of milligrams of KOH required for saponifying free fatty acid present in 1 gram of sample. Okay, I'll repeat, the number of milligrams of KOH. Over here we are finding out the number of milligrams of KOH which are required for saponifying the free fatty acid present in 1 gram of the sample. So what is the sample over here? We are taking glyceryl monostearate. So fatty acid which is present in the glyceryl monostearate, when we react with excess of KOH and heat it, that is we have to reflux it, it gives glycerol and soap. So if we take excess of KOH in this reaction, some part of the KOH will be utilized for the saponification and some part would be remain unused. So this unused part would be then used for titration, and then we can identify what is the saponification value. So it is important to take KOH in excess. So let us start with the experimentation. First part, we'll divide this entire experiment of HLB value, determination of HLB value in parts. So the first part of the experiment is saponification value of a given ester, to find out saponification value of a given ester. So over here, what is the step is, we have to first weigh 0.5 grams of ester, that is glyceryl monostearate. So this is how flaky glyceryl monostearate looks like. Then we have to transfer this 0.5 gram of glyceryl monostearate into RBF. RBF means round bottom flask. So we have transferred the glyceryl monostearate into RBF. What is the next step? We have to add 15 ml of zero point 0.5 normal alcoholic KOH solution. So to this RBF, in which 0.5 gram of ester, which is already present, we will be adding 15 ml of 0.5 normal alcoholic KOH. So KOH would be used for saponification. But what is the reason of adding alcoholic KOH? Alcohol would be utilized for solubilizing this glyceryl monostearate. So on the screen you can see RBF now, initially which had glyceryl monostearate. Now we have filled it with 15 ml of zero point 0.5 normal alcoholic KOH solution. Once this is formed, we have to heat it and reflux under reflux condenser for 45 minutes. So you must have seen this kind of assembly before, in which we are heating an RBF which contains a liquid. Okay, over here it is 0.5 normal KOH 15 ml, in which glyceryl monostearate is added, and then we are heating it and condensing it. So this would be heating and condensing. So this would be a cyclic, this entire system would be in a cyclic manner. We have to heat it, that is we have to reflux it for 45 minutes. After 45 minutes, cool the solution to room temperature. So once the reflux is done, we have to cool the solution to room temperature and we have to titrate it. So how we have to titrate it? Let us see. So this solution in the RBF, this is we have recovered after the reflux condensation, and we have cooled it. Then we will be adding phenolphthalein to this reflux condensed product. So okay, we are adding phenolphthalein. After addition of phenolphthalein, we will be titrating against 0.5 normal HCl. So over here we would be titrating against 0.5 normal HCl. So once you add phenolphthalein to the reflux product, as we have added phenolphthalein, initially the solution in the RBF would be pink. Okay, and in the burette we would be adding 0.5 normal HCl. So in burette we have filled burette with 0.5 normal HCl, and we would be titrating this with the reflux content. Slowly and gradually we have to titrate using 0.5 normal HCl till the color changes from pink to colorless. So endpoint over here is, initially it is pink, and after titrating it with 0.5 normal HCl, it would turn colorless. So just you have to mention, or you have to note it down, the titer reading, that is V1 amount of ml of 0.5 normal HCl which is needed. So amount of 0.5 normal HCl which is needed, here we'll note it down as V1. Then for blank would be repeat entire step from 1, 2 and 3 without using glyceryl monostearate. So that is, we have to take 15 ml of alcoholic solution in an RBF, but please note that we don't have to add glyceryl monostearate over here just because it is a blank reading. So RBF would be just filled with 15 ml of alcoholic KOH solution, reflux it for 45 minutes or 1 hour, cool to room temperature, and titrate again 0.5 normal HCl using phenolphthalein as an indicator. So the entire process which you have seen in step 1, 2 and 3 would be the same, but we will not be adding glyceryl monostearate. So after titrating, the titer reading over here for blank would be V2 ml of 0.5 normal HCl. So from this step, previous step and this step, we have now received two values, V1 value and V2 value. So V1 is the amount of 0.5 normal HCl which is utilized for the neutralization or for the titration, and which contains glyceryl monostearate initially, and V2 is the amount of 0.5 normal HCl which is required for titration but for a blank solution. So once we subtract the value of V2 minus V1, we will now give an amount of KOH which is utilized in the saponification reaction. So then we have to subtract V2, that is amount of HCl which was required previously, V2 that, and minus V1. This will give amount of KOH utilized in the saponification reaction. So this was the part 1. Second part is acid value. We would be now determining the acid value. What do you mean by acid value? the number of milligrams of KOH required to neutralize free fatty acid present in the sample. So over here we are determining the number of milligrams of KOH required to neutralize free fatty acid present in the given sample. So over here part 2 is determination of acid value. So what is this step? You have to take 0.5 grams of ester. Over here we have taking stearic acid. So weigh 0.5 gram of stearic acid and transfer it to a conical flask. Okay, we have to take a conical flask and transfer 0.5 grams of ester, that is stearic acid, into the conical flask. Then you have to add 10 ml of ethyl alcohol and 10 ml ether. So in the conical flask which contains stearic acid, we have added 10 ml of ethyl alcohol and 10 ml of ether, and you have to shake it till the stearic acid gets dissolved. So some amount of the stearic acid won't get dissolved. That is the reason we have to heat it using a water bath. There is a caution over here, students, as it contains alcohol and ether, it is highly inflammable. Just for the purpose of dissolving the stearic acid and forming a solution, we are heating it using a water bath, but you have to take utmost care during this time. So once the stearic acid is dissolved, now we would be adding phenolphthalein as an indicator into the conical flask, and now we would be titrating this against 0.1 normal KOH or 0.1 normal NaOH. So we'll be filling the burette with 0.1 normal, sorry, it is 0.1 normal KOH or 0.1 normal NaOH, and we would be titrating this against the solution of stearic acid which you have received. Titrate till color changes to light pink. So initially it is colorless and the end point would be light pink. So this is the V3 ml of 0.1 normal NaOH which is needed. So now the burette reading which we have received, or which you have seen, which you have observed, is the V3 ml of 0.1 normal NaOH. So in previous experiment it was V1 value, V2 value, and now we have determined V3 values. Okay, we have to just note down all these values, just because later on in the calculations we'll be requiring V1, V2 and V3. So this is the experimentation part of the acid value and saponification value. Then we'll calculate the saponification value. Okay, so saponification value can be calculated as volume of KOH utilized. So what was the volume of KOH which was utilized in the saponification value determination? It was the V2 and V1. So that is V2 minus V1. So ml of 0.5 normal HCl, when you subtract V2 minus V1, we will get volume of KOH which is utilized. You have to multiply this by normality of KOH. So what was the normality of KOH? We had used 0.5 normal KOH into the molecular weight of KOH. So that is 56 divided by weight of the sample in grams. So you have taken 0.5 grams of glyceryl monostearate for saponification value. So once you substitute the value of V2 and V1 in the given equation on your screen, you will then come to know what is the saponification value of the given glyceryl monostearate. Then comes calculation of acid value. So we have used either KOH or NaOH. Okay, so volume of KOH or NaOH, that is V3 volume. So once you get the V3 volume from the experimentation part of the calculation of acid value, this value can be taken into the formula which is there on your screen, multiplied by the normality of KOH and NaOH, that was 0.1 normal, multiplied by molecular weight of the KOH or NaOH, divided by weight of the sample in grams. So over here we have taken stearic acid 0.5 grams. So after substituting these values, you will get acid value. Okay, so now we have come to a point where we have calculated the saponification value, we have calculated the acid value. Now it is time to calculate the HLB value. So one of the method of calculating HLB value using saponification value and acid value is the formula, using the formula HLB is equal to 20 into 1 minus S upon A. So over here, once you substitute S, that is saponification value, and acid value, then you will get the final of HLB value. Okay, the final value of HLB of glyceryl monostearate. So I'll repeat. We have received the saponification value. We have calculated the acid value. So after calculation of saponification value and acid value, just substitute these S and A in the above equation of 20 into 1 minus S upon A, and it will give you HLB value. Okay. So here comes the results. So at the end of the experiment, you have to write down what is the saponification value, what is the acid value, and the HLB value of glyceryl monostearate. The last part which I would like to show you is this computation table. So students, you can note down this calculation part. It will help you whenever you carry out this experimentation. Directly you have to just carry out this experimentation. You have to substitute the values in the given format which is shown on your screen, and it will be very much helpful to you if you use this chart for calculation of HLB value of any given system. Okay, thank you.